Hello, Stat World! Welcome. All right, let's take a look at some of these problems, shall we? All right, let's see what we have here. According to Humane Society data, this is harder than I thought it would be. Ooh. There we go. According to Humane Society data, 39% of households in the United States have at least one dog. No horses? That's a good thing. In the United Kingdom, 23% of households have at least one dog. Suppose you select an SRS of 75 households in the US and 80 households in the UK, and you calculate the proportion of each. Which of the following best describes the sampling, ing, distribution for the two proportions? All right, so this is pulling in some old vocab for you. Sampling distribution, got it. So if we average together all of the differences, it should match the population parameters. So I just need to subtract my two values. If P1 is the United States, we'll put that number first, so 0.39 minus the UK, P2, which is 23%. So 39 minus 23, there you go. You have a mean of 0.16, so we can get rid of those two options. All right. Standard deviation time. Alrighty, we've got a big old square root we gotta run through for standard deviation. So for the United States, it's 0.39 times 1 minus 0.39 all over the sample size. Let's see, 75 households in the US, so 75 will be right there. Then we're gonna add to it the United Kingdom numbers. So for United Kingdom, it was 0.23, 1 minus 0.23, all over the sample size of 80. All right, let's grab our T.I. Joe and see what we can find. Woo! All right, so you're going to get your square root going. There we go. And then I'm going to use the alpha y equals shortcut so that I can get my fractions all set in there. So you have 0.39 times 1 minus 0.39 all over 75 plus. Alrighty, then we have 0.23 times 1 minus 0.23 all over 80. And there we go. 0.7. So standard deviation, get rid of those. So by default, E wins. We didn't have to do the normal check because there were no other choices, but that discount normal check is that n times p hat 1, well, I guess it's p, yeah, use p, greater than or equal to 10, and then you do the complement. And then you do the other one. Ooh, so many messages. Anywho, you want at least 10 successes and 10 failures for the United States and for the UK. And we do, so it would be approximately normal. All right, next up, we've got 2 large bins. It's hard to see. You have 2 large bins of marbles in bin A. 40% of the marbles are red, and in B, 52% of the marbles are red. You select a simple random sample of 30 marbles and then 40 marbles. What is the probability? Ooh, interesting. Okay, so what is the probability? Normal CDF looks that up for us. All right. We want the probability that the proportion of red marbles in sample A is greater than B. All right. We need a lower bound and an upper bound number, and right now we don't have that, so I'm going to do a little bit of algebra. So we've got A minus B, greater than 0. So that's going to give me my bounds. We're going 0 to infinity. All right. So if A minus B is the order of things, then I need to go in that order. So bin A was 40% minus bin B was 52%. And that's a negative 12% difference on average. And then the last thing I have to find is the standard deviation. So giant square root, we have 0.4, 1 minus 0.4, all over the sample size for bin A, which was 30. Then we have 0.52, oops, 1 minus 0.52, all over the sample size, which was 40. All right, grab that T.I. Joe. We've got a giant square root. And I can't see. Let's try that again. Can you see? Yes, you can see. All right, and then I'm going to use alpha y equals for my shortcut. 0.4, 1 minus 0.4, all over 30. Plus alpha y equals 0.52, 1 minus 0.52, all over 40. Yeah, looks good. All right, so we get 0.119 and some change. We don't want to round too much, because if we round too much, we might not see our answer over there. So I'm going to do 11933 and see what that gives me on my normal button. All right, so here we go. Normal CDF is going to look up our probability. We're going 0 to infinity. Negative 0.12 is our average difference. Give or take a spread of whoops, whoops, whoops. I just made a new song. Sounds really cool in my head, but you know. Okay, so 0.11933, and you get 0.157. Okay, so it looks like my closest answer there is E. It's going to be a little off just because, yeah, you know, there's decimals and rounding, but that's good. We got it. Okay, one more problem, which is good because I can't breathe in here. Whew, okay. An SRS of 100 flights. I can't do it. Woo! All right. I didn't want to pass out on you. That would be even more embarrassing. Are you okay, Mommy? I'm okay, little horse. All right, here we go. An SRS of 100 flights by Night Flight Airlines showed that 64 were on time. We have an SRS of 100 by Waxwing and showed 80 were on time. Let N be the proportion of on-time flights from Night Flight, and W is Waxwing. We're going to find a 95% confidence interval for the difference between these two proportions. All right, so let me run you to Stat World. We're doing intervals. We have two proportions, so I want to skip past test. We want to look for intervals. There we are. Two proportions, Z interval. All right, so my first proportion is N. What was N? Night flight. Okay, so night flight was 64 out of 100. So 64 out of 100. Then we're doing W, Waxwing. Waxwing was 80 out of 100. 80 out of 100. And we want 95% confidence, so 0.95, and calculate. All right. So the one that is closest is E. Wow, all the answers were E! That was totally not on purpose. I'm kind of creeped out by that. All right, well, let's move on to the next worksheet. I'm going to have to change costume ideas because I cannot keep teaching like this.